Hello, my name is Greg Vargas, and this is the NASA WebXR Group 16B Capstone 1 presentation. Alongside myself, Joshua Holloway, Osman, and Rushil Popat will also be presenting. Joshua and I are both computer systems engineering majors, and Fareed and Rushil are computer science majors. To start off, I'll talk about our project description. So the goal of this NASA WebXR project is to provide an easy-to-access WebXR experience to individuals in a museum setting. What this means is basically some kind of 3D environment or experience that users can use a QR code to access to easily interact with and learn about. The purpose of this project is to spread information to the general public about the Psyche asteroid mission in a fun and engaging way. We really want the general public that use this 3D experience to learn something from our experience and to come away with it feeling that it was fun to use. The motivation of this project is to enable the next generation of children to get excited about space exploration and increase public awareness of the current frontiers in astronomy and astronautics. So, in the past 20 years, there hasn't been a lot of space travel, so this is really one of the bigger missions to space that NASA is really pushing, and they really want the next generation of children, of space explorers to get excited for this mission because of the lack of really big, impactful missions in the past few decades. Along with that, we had to create the design requirements for this specific project. So as I said before, the goal is to create an educational interactive experience for museum visitors of all ages, particularly those without background knowledge. So we want it to be very insightful and for the museum visitors to learn about the mission when they interact with our project. So the focus and theme of our experience that we decided was the mission timeline. So from the rocket launch to the satellite orbiting the asteroid is those different stages of the mission are what we want to focus on with our project. And again, throughout this mission timeline experience, we want the users to get a greater understanding of Psyche and the goals of the mission. And so our product has to provide users with an experience that allows them to explore and learn about the different phases in the Psyche mission through this WebXR experience in different environments and using different 3D models as well.
So my name is Rushil, and I'm going to talk a little bit about the project requirements and the technologies we used in the project. Now, for the project requirements, we were given 3 basic requirements that we had to satisfy. The first one was to have the project operate in a browser-based 3D environment. Now, this browser-based 3D environment would primarily be accessed through mobile devices. So in addition to being compatible with every single major browser, it should ideally be optimized for mobile browsers that museum visitors would have on them. The second requirement was that the experience should inform visitors about the Psyche mission and the different phases of the Psyche mission. It is important that the information is in small, digestible pieces so as to not overwhelm visitors when they access the experience. Finally, and most important, the experience should be interactive and engaging, and users should learn the information in a fun and enjoyable way without being confused by complicated controls or navigation. The team has used a variety of technologies so far to create the experience, and this includes creation software, version control software, and communication software. In creation software, the team chose to use 3.js and tween.js as our JavaScript libraries of choice. The main backbone of the demo is 3.js, which is a powerful JavaScript library that can render and display 3D objects using WebGL technology. Tween.js is a helper JavaScript library that the team used for animation. In addition to these JavaScript libraries, the team also used Blender for making 3D models and textures. For version control and collaboration, the team used GitHub, which also serves as a web hosting site for the team's demo page. For communication, the team mainly used Discord, a messaging app, which allows for sharing of files, text, and video calling. Using Discord simplified the team's communication by a great margin. The team would meet on Discord voice chat weekly, and it greatly helped with progress, updates, and planning. In addition to Discord, the team also used Taiga.io for agile project management and project planning. Finally, the team also used Basecamp to communicate with stakeholders and the project sponsor.
Hi, my name is Josh. I'm part of Group 16B for the NASA WebXR Capstone, and I'll be explaining our design process. Initially, Fareed mentioned using Three.js, a web API that can be used to create 3D scenes inside HTML. This is a good start since our goal is to host the entire app through a web browser. After realizing that I could import GLTF files into Three.js, I got to work in Blender. We found basic untextured models on websites like Thingiverse, where users created them based off the concept art for the mission. Now, as a disclaimer, I don't claim myself to be an artist. In fact, I've never used Blender or Three.js before this project, so this was a substantial undertaking. Nonetheless, I went to YouTube and forum pages for guides and advice on how to texture these models. First, I started painting the asteroid to mimic what I saw on the Psyche mission page. There were large veins of iron spread out across the asteroid, with the craters exposing deposits beneath the surface. Though after painting it, it looked more like a toy instead of an asteroid. It had the shape of an asteroid, but no texture, just a perfectly flat plastic finish. So again, I went back to my online sources. I found that I could use PNG files of the texture I want on the asteroid, and by using the stencil in Blender, I could mix them into the colors. After overlaying a nice stone texture, the asteroid was really looking the part. I applied the same process to the probe with the texture of a solar panel and aluminum foil. When it came time to upload everything and start using it in Three.js, I encountered a few issues. First, the asteroid model was far too dense. I had to reduce its polygon count to 25% of what it was originally. Secondly, the shaders embedded in the models from Blender, such as bump mapping, didn't transfer well to Three.js, so they had to be removed. The size of the satellite had to be scaled down because its original size was over 100 times larger than the asteroid. Once I got through these hurdles, it was time to build a scene. Space is a dark, vast, and mostly empty place. I wanted to demonstrate that in our project. I started with a blank, or rather black, canvas. I found a PNG file of a lens flare from a tutorial project, and after a bit of coding, scattered 10,000 of these throughout the scene in a random pattern. The lens flares make for some nice looking stars. I found another suitable PNG file for the sun, but fixed it a long distance away and put a light source in it. Now there's a sun that casts accurate shadows on our models. In my opinion, the scene looks better than expected, all things considered.
So as of the most recent sprint, what we have right now to show for our project are two separate demos that we've developed called Journey and View Mission. So the first of these demos, the Journey demo, involves a representation within a 3D environment of each of the different phases in the Psyche mission. So you can see on the bottom left, there's a video I've recorded here where you start off on the main menu, and if you click the Begin Journey button, it will trigger a camera animation to transport you to the first phase in the mission, and then you can click the next and previous stage buttons to go back and forth along the timeline. And each phase has a 3D scene representing that phase, as well as some text to give the user a bit of background information on what the purpose of that phase is and what's going on in the scene. And we think this is sort of a basic version of what we expect the final product will be. Right now, we only have 3 phases represented in the Journey demo. So we hope to increase the number of phases until we can get a full timeline. The second demo we have, the View Mission demo, is based on the same concept, but instead of using camera animations to transport you between the different phases, it has each phase on its own separate web page, and then you can click on the right and left arrow buttons to transition between the different phases, as you can see of the screenshot on the bottom right over here. So we think that the value in our product is that it provides museum goers with a bit of a more engaging and fun way to learn about the Psyche mission, rather than just walk around and look at the different plaques and models. So we think that when the user comes to the museum, they can use our app and then learn a thing or two about the Psyche mission, about the different phases, what the timeline looks like, and that should hopefully get more people engaged with the mission and interested in learning more about it. And if we can get more people interested in astronomy and astronautics, then we feel that's always going to be a good thing, because it's just a very fascinating and very consequential field of study. So in conclusion, we've learned a lot about project organization and planning over the course of this semester. One of the things we really struggled with was in having regular meetings to talk about the project. We still had meetings over the course of the different sprints, but looking back, we think we could have used a lot more of those as a way to organize tasks and assign tasks to different group members. So going forward, we think that we kind of have a pretty good idea of what we think the final project, the product is going to look like. It will just involve us trying to flesh out the two demos we've developed right now by adding more content, so including more mission phases until we can get something that looks like a complete timeline, as well as making other aesthetic improvements, making the user interface more intuitive and more slick. And then in addition to that, making optimizations in technical areas. So for example, speeding up the time it takes to render the different 3D models and improving the frame rate. But considering that, when we started this project, we didn't really have much experience at all with 3D modeling and 3D rendering, and we kind of had to sort of cram for that and get familiar with the different APIs. I think we can be pretty happy with the work we've done so far, and we're excited to pursue the project further. So that about wraps up our presentation. We hope you enjoyed, and thank you for watching.